So if you have a positive, or if it says where is the graph positive, then that just means that you're looking for the part of the graph that's above the x-axis. And so here's my x-axis. And we're just going to use interval notation for this lesson. So what interval, and we need to use brackets or parentheses. It'll mostly be brackets in this lesson. But what interval is the graph positive from where to where?
0 to infinity.
-6 to 6. Good. So from -6 to 6. So what I'm saying is when it's positive means it's above the x-axis. Negative means that it is below the x-axis. And when you see an arrow, you just assume that it's going to be going the same direction forever. Negative, we are looking for the interval or intervals that are below the x-axis. And so I'm going to have two intervals, so I'll need to connect it with a U. So what's my first interval that's below the x-axis? So I would say -infinity to -6 union. And then what's the second one? 6 to positive infinity. Good. Yes. For zeros, we're looking for where the graph crosses the x-axis. So this won't be an interval, it'll just be x values. So where are my two x-intercepts? 6 and -6. So I would say x equals -6 and x equals 6. When the question asks me when is it increasing, I'm just looking for a positive slope. So think about as it's going from left to right, it's going uphill. So positive slope. So as I'm reading it from left to right, it's going uphill. Like I have a positive slope. No, it's like how you can understand it. It's going uphill. Positive slope. So from what interval to what is it going uphill, or is it have a positive slope? -infinity to 0. I guess you can put a bracket. Then for decreasing, it's going to have a negative slope. So it will be going downhill from left to right. So what interval is it going downhill or negative slope? 0 to positive infinity. Good. Then we have a local max and a local min. So anywhere that I have like the top of a peak. So when we did that polynomial unit, if it looked like a hill or something, so if you're looking for like the top of a peak, it's making like a hill or something. And that will be in terms of an ordered pair. So is there any local maximum from this graph? 0, 6, good. And then the local minimum kind of looks like the bottom of a valley. And you don't necessarily have to have a max and a min. So in this case, I don't really have a local minimum, so I would just say none. Okay, so for number 1, it is positive on the interval, so I'm looking at the x-axis. Everything that is above that x-axis is considered positive. So what interval did you get for the first part? -infinity to positive infinity. It is never negative. And even though it may touch 0, 0, that doesn't mean that it never goes below the x-axis. So then f of x has a 0 at x equals what? 0, because I have this point 0, 0. It's touching 0 and then it comes back, but it's still, even if it bounces, so it bounces off, but it touches 0. Oh, no, you don't have to say that.
What is it?
It could be. We don't have the function. So for the third part, f of x is increasing on the interval. So where do I have a positive slope or an uphill? 0 to positive infinity. Because it's uphill, like it has a positive slope this way. And then it's decreasing on what interval? Negative infinity to 0. And then it has a local minimum of what? 0 at x equals 0. Lots and lots of zeros. Okay, so f of x is positive on what interval? Negative infinity to positive infinity. Because it's approaching 0, but it never actually touches 0, so it is always positive.
So if it touched, then it would be something else.
Well, even if it touched 0, it would still be negative infinity to positive infinity, but if it ever goes below the x-axis, that's when it would become negative. So if it came down here, then that's when we would have some negative and some positive. But we have an asymptote at 0, so it approaches 0 and gets smaller and smaller and smaller and smaller, but never touches it. It's negative on the interval, so is it ever negative? No, so I would just say none. Does it have an x-intercept or a 0? No, so I would say none. No, just put none. Because we don't know if it has, this is an exponential function, so it wouldn't have imaginary solutions, just if it were a polynomial. It's increasing on what interval? Negative infinity to positive infinity. Because to the left, it's getting smaller and smaller and smaller and smaller. So if you're reading it from left to right, it's only getting bigger as you go along. So that would mean that it is never decreasing. So I would say none. Okay, so you could see, instead of a graph, you could see a table. And then the table would ask you the same types of questions. So one way is that you could actually draw the picture of the graph and plot all of the ordered pairs, like your x's and your y's. Or you could just look at the table and be able to tell what the graph is doing based on the table. So if your y values are increasing, then you have a positive slope. If they're getting smaller, then it's decreasing. If your y values are positive, then it is positive. And if your y values are negative, then it's negative. And so for number 3, it says, over which intervals is the function increasing? So if you're going from left to right, so from 0 to 3, which interval are the y values getting bigger? From 2 to 3, because it's getting smaller. It's getting smaller. Then it increases, going from 12 to 41. So I would say from 2 to 3. So if we're increasing, I'm looking for y values to get bigger. So it's decreasing from 0 to 1, decreasing from 1 to 2, then it's increasing from 2 to 3. So for number 4, it says decreasing, so what interval would that be? 0 to 2, good. So the next one, it says a fireworks projectile is launched 20 meters per second from a 60-meter cliff. The table shows the height in meters the projectile is above a field after X seconds. And so number 5, it says over what interval is the projectile's height increasing? So I want to do the same thing. And sometimes it helps for me to put plus and minus signs, so we could go ahead and do that. So from 60 to 75, it's increasing. 75 to 80, increasing. 80 to 75, decreasing, decreasing, decreasing. So to answer number 5, what interval is it increasing from what to what? 0 to 2, good. And then decreasing 2 to 5. Perfect. So then domain and range based off of a table is a little different. Domain is easy because you're just going from the least to the greatest of your x values. So my domain would be from 0 to 5. And there's no way for us to tell if there are any holes or anything like that. So we, and especially in word problems, it's okay to assume that there are no holes or gaps, that it's just a function that is continuous from least to greatest. And then for the range is a little different because it doesn't necessarily go in order. It's going from least to greatest. So in my y values, what's the smallest number? 35. And then what's my biggest number? 80. So my range would be 35 to 80. So I'm going from least to greatest, and it may not necessarily be in order from left to right, but if you could imagine what the graph would look like, my smallest y value to my biggest y value. Okay, so for number 8, it's increasing from -2 to -1. That's where it is an uphill slope. Then it goes back downhill from -1 to +1. Then it goes back up from 1 to positive infinity. Max would be where you have the hill. So the ordered pair is -1, 4. So you would put parentheses around it because it's an ordered pair, like it's a point. And then my minimum would be down here where you have the valley. Those are just local maxes and mins because obviously it goes on forever up. So you're going to get higher and higher values, but you say local because that's all that you can see on the graph. And so the zeros would be -2 and +1. Domain is -2 to infinity. Range is 0 to positive infinity.